Today we're going to start our look at Chapter 10, which is on trigonometric graphs, identities, and equations. Today's lesson is on section 10.1, graphing sine, cosine, and tangent functions. There are two learning targets in section 10.1. Learning target 10.1a is I can graph a sine, cosine, and tangent function. And learning target 10.1b is I can identify the amplitude, period, intercepts, minimums, maximums, and vertical asymptotes of the graph. We're going to start out looking at some characteristics of the graphs of y equals the sine of x and y equals the cosine of x. The domain is what we're going to start with. And remember, domain is what those x values can be. So what we can take, so what we can plug in for that x. So our domain is always going to be all real numbers. So there is no restriction on what you can take the sine and the cosine of. We're also going to look at the range. The range, remember, then is the y values. So the range in both the sine and the cosine will always be between -1 and 1. So that's what the sine and cosine will always equal, be some number between -1 and 1, meaning that the minimum is going to be -1. The maximum is going to be a +1. A couple other characteristics that we have of the sine and cosine curves are the amplitude. So the amplitude, when looking at the sine and cosine, the amplitude is how high or how low the graph goes. So the amplitude is going to be equal to half the distance from the minimum to the maximum. Or if looking at the graph, it's how high the graph goes or how low it goes. But remember, amplitude will always be a positive number. So in the case of just the plain y equals sine of x and y equals the cosine of x, that amplitude is just 1 because it only goes as high as 1 and it goes as low as a -1. But then once we start adding numbers in here, that's going to change the amplitude. We also look at what is called the period when looking at sine and cosine curves. And we have a period, or it's periodic, when a graph repeats. So the same chunk of the graph repeats every so often. And that's what happens with the sine and cosine, creating what is called a cycle. And the cycle is the shortest repeating portion of the graph. So it's the part that is repeating. Get down to the very smallest part that you could just repeat every single time. So then that period is that horizontal length of each cycle. So how long it takes to get through one of the repeating periods. For just a plain sine and cosine curve, before we start adding numbers in, the period is always going to be 2 pi. And typically we do it in radians. You could do it in degrees, but in degrees that would be the 360. But we're going to focus on the radians in this chapter when graphing, so that means our period for a plain sine and plain cosine will be 2. Now, once we start adding other numbers in there, we'll start looking at what that does to the period. But for now, if there's no other numbers in there besides what is written at the top of this slide, then the period is just 2 pi. So now let's look a little bit closer at that sine and cosine graphs. Like I said, we're going to add some numbers in, and specifically today we're going to look at just adding numbers right in front of the trig function, so that's going to be those a values, and then right after the trig function or also in front of the x value, so a number that's attached to the x value, which is going to be then your b value. So what that does is it affects both the amplitude and the period that we just talked about. So the amplitude now when there are numbers with our sine and cosine is going to be equal to the absolute value of whatever a is. So whatever that number in front of the sine and cosine curve is, or equation is, that's going to be what the amplitude is. And keep in mind, like I mentioned on the previous slide, the amplitude is always going to be positive, so that's why we do the absolute value of it. And the other thing I said that it affects is the period. So the period of the graph, remember, is how long it takes for it to repeat that one cycle, that part that's repeating. The period is always going to be take that 2 pi that we said originally it was and divide it by b, or the absolute value of b, because period we want to always come out to be a positive number. So take whatever is in front of the x, put it on the bottom, so it's 2 pi divided by whatever was in front of x. That is now your new period. So with that comes what I like to call the markings. So when we go ahead and figure out where the different points on the graph are, we need to know where the markings are going to be, because we always make 5 marks, or 4 marks if we use the axes. And that the markings are going to be found, or how often, what the space between them is going to be, is that period that we just found divided by 4. And that, we'll get into, once we start graphing it more, you'll see where that period or the markings come from. When graphing both the sine and the cosine function, we're going to use the 5 key points to help us graph it. So once you find those 5 key points, you connect the graphs, and then you've got that first cycle. So the 5 key points are going to be found at maximums, minimums, and x-intercepts. And just depending on whether you're looking at a sine curve or a cosine curve will depend on how many of each you're looking for. But remember, there are only going to be 5, so that means, we're going to double up on a couple of these, and then that'll give us those 5 key points. So now when graphing these, let's look at the general sine graph. So this would be when y equals the sine of x. So no numbers are added to it, and that's, we'll start adding the a and the b value, and that'll change this. But for now, the plain sine curve, this is what this kind of pinkish reddish line is the graph of. And there are, like I talked about earlier, 5 key points. To start the cycle, which in this case would be this point right here at the beginning. Oops. So this point here at 0, 0. We also have then the highest point, this point up here at the top, and then back down to 0, so this point in the middle, back down to the lowest point, and then back up to the middle. So there is, and I'll kind of maybe outline it, highlighted in yellow. Oops, and back up. So that is our first, what I highlighted in yellow, that is our first cycle of the sine. So that is what then gets repeated multiple times to the right and then multiple times to the left. And like we said earlier, there's those 5 key points at 0, 0, one up there at pi over 2, back on the axis at pi, down at our low point at 3 pi over 2, and then back up on the axis at 2 pi. So we've got our 5 key points. Once you get those 5 key points on the graph, then you just connect them and then make your first cycle. And when graphing these, I'm only going to have you graph just one cycle. I just want that main cycle. But just know that that does get repeated both to the left and to the right of the main cycle. Let's now look at the cosine. Cosine is a little bit different. The sine, when going back here to the sine, notice that the sine always started at 0, 0. But now when looking at the cosine actually starts up at 1. So remember, this is y equals the cosine of x. So it starts up at 1, it dips down and touches the x-axis, goes all the way down to the minimum, back up to the x-axis, and then back up to a maximum. So with the sine curve, we had x-intercept a maximum, we had another x-intercept, we had a minimum, and then we had another x-intercept. Those were our 5 key points. Now when looking at the cosine, it starts up at that maximum, so it has a maximum value. Then it had an x-intercept. Then it has a minimum value. Then it has an x-intercept again. And then it has another maximum. So it's a little bit different from the sine because that one had 3 x-intercepts and 1 min, 1 max. This one has 2 maxes, 1 min, and 2 x-intercepts. And again, just to highlight it, just to give you a rough idea, starting up, dipping down, coming back up. That is our first cycle of the cosine. So then that is what gets repeated off to the right and off to the left. But again, there's those 5 key points. Cosine, remember, starts up at the amplitude. So starting up at 1, going down to the x-intercept at pi over 2, all the way down to a minimum at pi, back up to 3 pi over 2 at an x-intercept, and then all the way back up to a maximum at 2 pi. So now let's look at a couple examples that start adding some of these numbers in. So my first example is y equals the sine of 3x. And with this, what I want to do is I want to graph this equation. So we're going to graph the function. So to do this, the first thing we want to do is look at any numbers that happen to be in the equation. In this case, there's that 3. Well, a 3 in front of the x affects the period. So that tells us then that our amplitude, so when I graph it, I always identify my amplitude and my period first, just to help me graph it. So the amplitude in this case is just going to be 1 because there is no number written in front of the sine. So then the period is equal to 2 pi divided by the b value, which in this case is 3. So now we're going to use that to graph. And remember earlier when I mentioned something about the markings, so the markings can be found at the period, which in this case is 2 pi divided by 3, divided by 4, which is the same thing as times 1/4. So 2 pi over 3 times 1/4. Well, the 2 goes in the 4 twice, so I end up with pi over 6. So every pi over 6, I'm going to have a mark on my graph. So I'm going to go ahead and make my graph. We do know that our amplitude is 1, knowing that I'm going to go up as high as 1 and down as low as -1. So I don't have to, make my graph too tall because I am only going to 1, -1. Now we want to make sure we stretch it out some so it's not squished down and so tiny that you can barely see it. So I did stretch them out just a little bit. So now when graphing this, it's a sine curve, so that tells me I do start at 1, or sorry, I do start at 0, 0, 0. Remember, is my starting point when graphing a sine. So I'm going to start there at 0, 0. And then I need to figure out where those markings, there's always going to be 5 key points. So I know then my first one was at 0, so, and then 2, 3, 4, 5 with a sine curve. Remember the order that it goes in. So the sine started at 0, 0, then it goes up to a maximum. So then my maximum, remember, is going to be at 1, back down to an intercept, so I put it at an intercept, down to the minimum, which we said earlier was -1, and then back up to my x-intercept. So there's my first curve. So I could go ahead and connect it, and then I'll add in the values later. So when I connect it, you just kind of connect it the best you can. Just don't make straight lines. Make sure that they're all curved. If you make them just straight lines, I will count off for that. But if I can tell you're trying to make it curved, then that's good. Make sure you put arrows on the end to show that it is going to keep repeating. But I do only make you make that one cycle because I assume then that you'll be able to repeat it after that. So now to figure out where these markings are at, we do know that our period is 2 pi over 3 long. Since I started at 0, that means I'm going to end at 2 pi over 3. So that helps. And then to get the next ones, the easiest way, or there's a couple ways. One is to use those markings, so I know that the first one is going to be pi over 6. And then I have to, every one after that is going to be another pi over 6. So if I add another pi over 6, that gives me 2 pi over 6, or pi over 3. And then, so that was 2 pi over 6. If I add another pi over 6 to that, that gives me 3 pi over 6, or pi over 2. So again, that was 3 pi over 6. Add another one, gives me 4 pi over 6, which reduces down to 2 pi over 3. So that is my last mark. That, is one way to do it. The other is to know that since this last one here is 2 pi over 3, if I do half of that, or divide it by 2, or multiply by 1/2, that's going to give me this one, which when I do multiply by a half, it does give me pi over 2. And then when I do half of this pi over 3, that's going to give me this. Half of pi over 3 is pi over 6. And then to get that one in the middle, that pi over 2, I would just have to average the 2 on either side to find that middle one. So take pi over 3 plus 2 pi over 3, which gives us a pi, divide it by 2, gives us 2 pi, and that's where we found this one to be. But once I have my markings, I need to make sure that my x-axis is labeled like we just did, and my y-axis is labeled so that I can see what the period or the amplitude is. Once I have those things on there, I've connected my curve, then we've got our graph. Okay, like I said, that's all. I just need the one cycle. Once you've got that one cycle, then you're good. So now let's look at a second example. This one uses the cosine, and this time that 3 got put out front of the cosine. Again, remember, sines and cosines work the same. It's just where you start is different. That's the only difference between the two. So this case with the 3 out front, remember the 3 out front affects the amplitude. So in this problem, the amplitude is actually 3 because that is the number that's out front of my trig function. The period then is still going to be 2 pi divided by the b value, but in this case there's nothing with the x, or that coefficient of x is just 1, so my period is just 2 pi. So when going to make my graph, it's still going to be at the basic, starting at 0, and then the 1, or the 2, because that would be my second point, 3, 4, 5. The fifth point is going to be out at 2 pi. So then with cosines, let's go ahead and graph this. So cosine, oops, I gotta change our amplitude. So the amplitude is, because it has that number out front, is going to be 3. So 1, 2, 3 is going to be the highest point it's going to go at. 1, 2, 3. Negative 3 is going to be the lowest that it ever goes. So when graphing it, a cosine curve always started up at that amplitude, up at the maximum value. So I'm going to put a dot there. Then it dipped down to the x-intercepts, all the way down to the minimum, which in this case is negative 3, back up to an x-intercept, back up to a maximum of 3. So then again, once I've got those 5 key points there, now I can go ahead and connect them. Again, try to make it as curved as possible. And my line got a little thicker there, so you can't see those points as well anymore. Maybe I'll change the color and put those points back in. So I had a point up here at 3, the 0 and the 3, back at the intercept, down at the minimum, back up to an intercept, and then back up to a maximum. So those are the 5 key points. Now I just need to get it labeled on my axes. So since I know that it ended at 2 pi, when I do half of that in the middle one gives me pi, half of that again gives me the pi over 2. And then if I average the 2 to get that fourth marking, so I add, so I get 3 pi divided by 2, so 3 pi over 2 would be that fourth marking there. So again, once I have both axes labeled, I've got my first period of this graph drawn, 5 key points marked, then I'm good to go. So that's what those two right there is your learning target So both A and B are going to be the learning target 10.1A, and it's graphing the sine, cosine, and tangent function. So that's an example of learning target 10.1A. So now the 10.1B, what it actually wants you to do is, so I'm going to maybe put this in green, 10.1B is identifying all those important parts. Now for part of it, we did need it to graph, so we do have some of the answers. So some of the things you have to identify is the amplitude, so there's the amplitude, the period, so there's the period on the first one. But then other things that you have to do is the mins, the maxes, and any x-intercepts. So by those you can just pick off the graph. So minimum, or the lowest point, in this case is going to be this point right down here, so which would be the point pi over 2 and -1. So there's my minimum value. I also need maximums, which in this problem I would actually have only one of them also, which would be this high point here at the beginning, which would be at pi over 6, 1. So once I have the graph, part B is just picking off values off of the graph. And then the last thing I need to do is my x-intercepts, which for this problem I actually have 3 of. I've got the first initial one, which was 0, 0. Let me erase these arrows down here so I have a little more room to write. The next point is right here in the middle, which is the pi over 3, 0. And because they are x-intercepts, your y value should always be 0. And then the last x-intercept is at 2 pi over 3, 0. So the 5 things that they asked us to identify were the amplitude, the period, minimums, maximums, and x-intercepts. So again, amplitude and period, you're going to need to graph it, but then the rest you just pick off of the graph from there. So now let's look at the second graph and pick off the same things off of the second graph. So again, we already identified our amplitude because that was needed to graph. The period, we also needed that to graph, so that's the 2 pi. And then minimum, this graph only has 1. The minimum value is at pi -3. That's this point right down here. We have 2 maximum values. We have 1 up here, which would be at the point 0, 3, and then 1 right here, which would be at the point 2 pi 3. So there's our 2 maximums. We had 1 minimum, and then the last thing we need is the x-intercepts. So I will try to squeeze that down here. So the x-intercepts are these last 2 blue points that are on the graph. So the first one is at pi over 2, 0, and the next one is at 3 pi over 2, 0. So there's your x-intercept. So again, part B should just be a matter of picking things off the graph. So once you've got the graph of everything, you use your amplitude and period to graph the sine and cosine, and then pick the rest of the things for learning target 10.1B off of the graph. Let's look at one more example of graphing a sine or cosine function. So let's graph y equals 3 cosine of pi over 2x. So I always start by identifying my amplitude. So look at the number out front or right directly in front of your trig function. In this case it's a 3, so my amplitude is 3. Now keep in mind, if that number out front of cosine would have been, say, a -3, the amplitude would still be 3. Amplitude is always positive. And then I'm going to look at the period. The period is 2 pi divided by whatever's in front of x, which in this case is pi over 2. So it's 2 pi divided by pi over 2. So now remember to divide fractions. We can do 2 pi and then do your leave change flip. So leave it as 2 pi, times it by 2 over pi, because I do the reciprocal of what's on the bottom. When I do that, I can think of the 2 pi as 2 pi over 1. So then when I multiply straight across, my pi's will end up canceling, giving me just 4. So the period for this, the pi's end up going away, so the period is just 4. So from start to end, it's going to be 4. So let's go ahead and look at that. My amplitude is 3, so I want to make sure that I can get up to positive 3, get all the way down to a negative 3, and then it is a general, or the sine and cosine, so I'm going to start at 0 as my first point. So then there's point number 2, 3, 4, and 5. That last one, remember, is going to be out at 4. So now when putting that graph on here, it is a cosine curve, so it starts up at the amplitude, meaning it's going to start all the way up here at 3. It's going to then dip down to the x-axis. It's going to dip all the way down to the minimum, back up to the x-axis, and then back up to a minimum. So then I can go ahead and connect those points to get my cosine curve. So when I connect them, again, just try to make them as curved as possible. Put some arrows on to show that it is going to keep going. Again, don't make it straight because then it's not a sine curve anymore. So you've got to make sure it has some curve to it, and it hits those 5 key points. And the last thing for the graph that we need to do is identify the markings. It makes it a little bit easier since the pi actually canceled out for the period. Since the full period is 4, when I do half, it means it's going to be a 2 here in the middle where the minimum was at. And then half again gives me a 1 for that first point. And then the average of 2 and 4 is 3, so that's what goes in the middle there. So there's 10.1a, the graph of y equals 3 cosine of pi, or pi over 2x. Let's go ahead and extend it back out to the learning target 10.1b, which is to identify all those key points. So the amplitude we already said. I'll just rewrite it. The amplitude was 3. The period we found earlier to be 4. Then it wants us to identify any mins and any maxes. Well, because it is a cosine curve, there is only one minimum. The minimum can be found at the point 2, negative 3. The maximum then, there are 2 maximums. First one being at 0, 3. The second one being at 4, 3. And then the last thing they want us to identify in 10.1b is the x-intercepts. When reading 10.1b, it does say that we need to be looking at any asymptotes, vertical asymptotes, but sine and cosine curves don't have asymptotes, so that's why we don't have to identify them here. So there would just be these 5 things for the sine and the cosine curves that you're going to have to identify. If it happens to say vertical asymptotes, you just put none or does not exist, because there aren't any for sines and cosines. No asymptotes for sine and cosine curves. So back to this, the last thing we needed was those x-intercepts. First x-intercept is going to be at 1, 0, and the second x-intercept is going to be at 3, 0. So those 5 things are what we need when identifying, or when looking at learning target 10.1b.